We are now going to follow the same procedure, except that we're going to represent everything by a matrix. The equation 3x plus 5y equals 9 is represented by this row. The equation 2x minus 4y equals negative 6 by the second row. We make the convention that whatever's in the first column is a coefficient of x, whatever's in the second column is a coefficient of y. We have a dotted line here, and whatever's to the right of the dotted line is what's on the other side of the equal sign. Now recall that we multiplied the first equation by 2, the second by negative 3. So we're going to do 2 times the first row here. That's going to give us this, doubling each of these numbers. Negative 3 times the second row gives us these numbers. We then proceed to simply add the 2 rows. Our goal here was to eliminate the x from the second equation, essentially, which is to eliminate the 2 and replace it with a 0. So if we add the 6 and the negative 6, we accomplish that. 10 and 12 gives us 22, 18 and 18 gives us 36. So here's the system. Now this just corresponds to the 6x plus 10y equals 18, the 22y equals 36. What did we do next? We divided both sides of this equation by 22. So we divide this row by 22 and we get this row. This row represents y equals 18/11, which of course is what we got. If we then rewrite that same equation here, we can see that what we want to do is, this equation represents y equals 18/11. If we could get a 1 over here and a 0 here, we'd have an x equals whatever's over here. So our goal is to get a 1 here. First, we're going to get the 0 here. So how do we do that? Well, we take 10 times the second row, which will negative 10 times the second row, which will give us a negative 10 here, and get rid of this 10 when we add the 2 rows. So we do the first minus 10 times the second. We'll have 10 minus 10 times 1 gives us the 0. 18 minus 10 times 18/11 gives us the 18/11 here. And now we've got a 6, 0, 18/11, 0, 1, 18/11. This stands for the 6x equals 18/11. We want to know what x is. We want a 1 here. So what do? We simply divide this equation by 6, and we get this. Okay? Now, in terms of the numbers in the matrix, what we've done is we've attained the identity matrix over here, and that's our goal, to get the identity matrix on the left-hand side. And it seems that at some point I stopped writing down my dotted lines. Let's put those back in, just to be sure we understand where that identity matrix is. But this is it. So this is our goal, to attempt to get the identity matrix. Turns out we can't always do that, and that tells us something about how many solutions we might have to the system. But that's what we're trying to do, and in the process, turns out that we can learn a lot about the system. Now, again, we started with this matrix representing the equations, and we've reduced this matrix down to the identity, which reduces this side down to the solutions. Okay, here we have the identity, here we have the solutions, the x and the y.